When we talk about sign of the function values, excuse me, we're talking about positive or negative. When are they positive and when are they negative? And that's going to be really, really important. So what you can think of is the coordinate plane and the four quadrants. 1, 2, 3, 4. But I told you yesterday to remember sine goes with y, cosine goes with x, tangent goes with y over x. If you've memorized that, then this whole table should be easy to fill out, and it should be kind of easy. So think about an xy point. If we are in the first quadrant, okay, think about a coordinate pair that would be in the first quadrant, okay? Any x number you pick, any y number you pick, both of those numbers are going to be positive. So if you think about the x number is going to be positive, then you would know cosine is going to be positive in the first quadrant. Likewise, if you know the y coordinate is positive, then sine must be positive in the first quadrant. If you divide y over x, then tangent is going to be positive. Now, yesterday we also learned that the other three functions that I haven't listed yet are just the reciprocals of the big three. Cotangent is the reciprocal of tangent, so it's the same. And secant goes with cosine, and cosecant goes with sine. So all 6 of the trig functions are going to be positive in the first quadrant. That makes sense because everything is positive in the first quadrant. So if you look at the second quadrant and think about an xy pair, which of the numbers is going to be positive? The y value would be positive in the second quadrant. It's going to be like -3, 4, right? Excuse me. So if the y coordinate is positive, that means sine is positive and cosine is negative in the second quadrant. Tangent, you divide y over x. If you divide those two, you're going to get a negative. And then the other three just fit off of those three. Cotangent goes with tangent, secant goes with cosine, cosecant goes with sine. In the third quadrant, x and y are both going to be negative. So sine and cosine would both be negative. If you divide those two, y over x, that's going to give you a positive value. So then cotangent is positive like tangent, secant and cosecant are negative like cosine and sine. In the fourth quadrant, x is positive, y is negative. So like a coordinate would be 5, -1. That would put us in the fourth quadrant. That's what I'm talking about. X is positive, y is negative. X is positive, y is negative. Divide those two, and tangent would be negative. Cotangent is with tangent, secant is with cosine, and cosecant is with sine. So that's a pretty big deal. Now, you do not have to memorize that entire chart, because if you just memorize that sine goes with y and cosine goes with x, and tangent is y over x, you can figure everything out. And that is going to be very important that you can do that. So this thing down here is kind of another way of remembering the same exact thing. If you look at your coordinate plane, all right, they say all functions are positive, sine and cosecant are positive, tangent and cosine. Okay, just shorten it down to this. And I want you to remember this mnemonic device, okay? All students take calculus. It's kind of a silly thing that doesn't really mean anything. All students take calculus, but that's going to help you remember which of the trig functions are positive, okay? Which of them are positive. So in the first quadrant, all of the things are positive, okay? All 6 trig functions are positive. In the second quadrant, S for students, all students. S is supposed to remind you of sine, and sine is positive in the first quadrant, okay? If sine is positive in the first quadrant, but sine and cosecant go together, okay? I said first quadrant, I meant second quadrant. Sine and cosecant go together, so sine and cosecant are the two that are positive in that second quadrant. In the third quadrant, T stands for all students take. T stands for tangent. And so you're looking at tangent and cotangent are positive in the third quadrant. In the fourth quadrant, C for all students take calculus. C is supposed to make you think of cosine. Okay, cosine is positive and its partner, secant. Okay. I think I'm still recording. Which of the 6 trig functions of theta would be positive? When you look at 87, you have to think about what quadrant we're in. Okay, 87 degrees is in the first quadrant. How do I know that? Well, I kind of just picture an 87 degree angle is going to be right there. It's in the first quadrant. And we know all students take calculus. All 6 trig functions are positive. So that's the answer. All 6 are positive. Question says, which of the 6 trig functions are positive? So that means sine 87 degrees is positive. Cosine 87 degrees is positive. That kind of thing like that. 300 degrees. You really want to picture where that is. 300 degrees is going to put me down in the 4th quadrant. So again, if you think about all students take calculus, that would tell you that cosine and its partner, secant, are positive. Negative 200, go around backwards, a little past 180 is going to be right there, puts us into the 2nd quadrant. Okay, we are in the 2nd quadrant. So all students take calculus. I know that sine and its partner, cosecant, are positive there. Number 6, identify the quadrant or quadrants of any angle that satisfies the conditions. Okay, so we're looking at this. When it says sine theta is greater than 0, that's telling you that it's positive. And tangent theta is less than 0. That's another way of saying that it's negative. So they're saying that sine is positive and tangent is negative. So if you look at your little device here, all students take calculus. We know sine would be positive. I call this upstairs, okay? Upstairs. I think about sine as the y, and y values would be positive upstairs, up on top of that graph in the 1st and 2nd quadrants. But we know tangent would be negative. Okay, you got to think about this. This isn't very straightforward, but tangent would be positive in the 1st and the 3rd. All students take calculus. That's where tangent would be positive. So I want the negative. Tangent is going to be negative in the 2nd and the 4th. So we're looking for where both of those things happen. Where both of those things happen is here in the 2nd quadrant. That's the answer. Quadrant 2. That's where sine is positive and tangent is negative. The next one's kind of silly. First thing says, where is cosine positive? Okay, well, cosine is an x number, and x numbers are positive on the right side of that graph. Okay, 1st quadrant and 4th quadrant. But then when it says secant is negative, secant goes with cosine. So basically they're saying, where is cosine negative? And cosine is an x number. It's negative on the left side. X's are negative in the 2nd and 3rd. So what this is saying is kind of nonsense. It's saying, where is cosine positive and negative at the same time? This is not possible. Okay, I'm going to stop there. When we talk about a range, we've done this before, and it's probably easiest if you just think about the graph. Okay, if I graphed sine theta, we can see this, and you look at that graph. Tell me what the domain is. What's the domain? All real numbers, right? Okay, can you see what the range is? From -1 to +1? Yeah, you just look at the y numbers. It's from -1 to +1, okay? Great. That is exactly what this thing says right here, right? That's the range from -1 to +1 for a sine theta and a cosine theta. That's the range, okay? If I looked at a tangent graph, tangent theta, okay, tangent theta looks kind of weird, right? Check it out. That's what a tangent graph looks like. Okay. The domain's kind of hard to do because there's like a bunch of missing spots. There's a bunch of asymptotes, but the range is still going to be all real numbers. You squash that onto the y, that's all real numbers. And we can see that right here. That's the range, okay? But then if you look at a secant graph, people get confused by this, but it's two pieces, right? There's two pieces of the range. So let's look at what a secant graph looks like. All right, kind of a weird looking thing. Weird looking graph, but you definitely are going to see two pieces if you squash that onto the y-axis. All right. If you zoom in, we can see that essentially it's going to be everything that's not in between -1 and 1. So it's almost like it's the opposite of sine theta. All right. Okay. Almost, not quite. Okay. So it's from -infinity to -1 unioned with 1 to infinity. So you need to know what range means, all right? If you don't know what range means, then that's kind of a bad thing, okay? When I ask students what is domain and what is range, they almost always will say it's the x numbers or it's the y numbers, but that's not a very good answer, okay? What is domain? Domain is what I'm allowed to plug in, okay? If I took a problem and I said, sine 87 or whatever, okay? The domain being all real numbers means I'm allowed to plug whatever number in the world that I want to plug in, okay? I can plug in anything, okay? But the range, we said the range was between -1 and 1. That means that my answer, my output number, has to be somewhere in between -1 and 1, okay? So if I did sine 87, if I did sine 54, whatever. I'm going to get some number in between -1 and 1. That's what range means, okay? Yes, I know we can understand it better when we look at a graph, but we're talking about the y number. If I was talking about a sine graph, okay, the y value is always going to end up being something in between -1 and 1, and that's what I'm talking about here, the answer, the output. Okay, so number 7, determine if these things are possible. Okay, is it going to be possible for me to get an output value of 2.5 here? That's not possible, okay? That's not possible because the range is between -1 and 1. That means the answer is going to be between -1 and 1. 2.5 is not possible. How about tangent theta equals 110.47? Is that possible? That is possible because the range on a tangent is all real numbers. How about secant theta is 0.6? That's impossible or not possible because the range, again, the range is that weird thing that's just everything outside of -1 to 1. Impossible, not possible. Example x2. Oh, I forgot I can do this. Suppose that angle theta is in quadrant 2 and sine theta equals 2/3. Find the values of cosine theta and cotangent theta. All right. This problem looks an awful lot like some of the examples we did yesterday. But it's going to be super important that you pay attention to this extra piece of information, that it's in quadrant 2. Okay? So let's think about what we would have done yesterday. We know sine theta goes with y. In fact, we call it y over r. So we can say that ratio of 2/3 is basically the same as our ratio y over r. And what you can't really say that y is 2 and r is 3, but we know that ratio works, okay? So that's kind of what we're going to go with, all right? So if we look at cosine theta, think about what we were doing yesterday. Cosine theta equals x over r, and cotangent theta equals x over y. The thing we're missing there is we're missing that x value, okay? So let's do what we did yesterday. Yesterday we had this formula that said r equals square root of x squared plus y squared. And what we can do here is we can stick that 3 in for r. And we don't know what x is, but we do know that we're calling y that 2 there. And we'll solve this equation. 3 equals the square root of x squared plus 4. I'm going to square both sides, which gives me 9 equals x squared plus 4. Subtract the 4 over, and that gives me x squared equals 5. And what a lot of people will mess up here, a lot of people won't give me both solutions. There are 2 solutions to this, okay? There are 2 solutions to this equation, x equals plus or minus square root of 5, all right? But we know we're in quadrant 2. And what do we know about x values in quadrant 2? So let's just use the negative version because we're in quadrant 2, okay? That's going to be very important. A lot of our problems from here on out, you're going to have to do that, and you're going to have to think about where we are so you know if it's negative, okay? So x is negative square root of 5. We can call this ratio negative square root of 5 over our r value was 3. And x was negative square root of 5. And our y value was 2. So maybe we should have drawn a picture of this, okay? Maybe we should have done it this way, but think about what they're describing. They're describing some angle in the second quadrant, okay? There's some point on this angle, and what happens is that point on that angle describes a right triangle. So when we had that sine ratio was 2/3, we've got the y side and we've got the r side. So basically what we're doing is Pythagorean Theorem, okay? If you just did straight Pythagorean Theorem, a squared plus b squared equals c squared, you could find this missing piece of square root of 5, okay? But you absolutely have to think about being in the quadrant 2 so you can say that this is negative, okay? That x value we're going to think about that x value as negative 5. It's not that we're calling the side of the triangle a negative value. It's that we're talking about this coordinate, okay? This coordinate has a negative x value and a positive y value. That's because we're in the second quadrant. But regardless of whether you draw a picture or not, you're still going to get the same answers. Pythagorean identities are special kind of formulas that you can use sometimes. And the first one, sine squared theta plus cosine squared theta equals 1. That's one that you should probably have memorized. Sine squared theta plus cosine squared theta equals 1. Then there's tangent squared theta plus 1 equals secant squared theta. And then there's also 1 plus cotangent squared theta equals cosecant squared theta. I would have the red one memorized. You probably won't need to memorize the other 2, but definitely the red one. Quotient identities. You might already know this one, but tangent theta is equal to sine theta over cosine theta. And this should make perfect sense if you've already memorized that tangent is y over x, and sine goes with y and cosine goes with x. So this should make a lot of sense to you. Cotangent theta, if you remember that cotangent is the reciprocal of tangent, this one should make sense to you as well. Cotangent theta is cosine theta over sine theta. So there are some formulas. You're going to have a formula sheet later. You don't necessarily have to remember these or memorize these, but I would remember the red ones for sure. Example x3, find sine theta and tangent theta given that cosine theta equals -3/4 and sine theta is greater than 0. Now, I suspect they want us to use the Pythagorean identities from before, but I'm going to show you the other way, the way that you've already been doing, because I think it'll be faster for you and more convenient. So I guess the thing that's different from yesterday is you have to pay attention to statements like this, okay? Sine theta is positive, and notice this right here tells you that cosine theta is negative. So if you think about where is sine positive and cosine negative, that's describing quadrant 2. So you kind of have to think about that. Maybe not necessarily now, but at some point you're going to have to think about that. So let's do what we would have done yesterday. Cosine theta, we know cosine goes with x. X over, whoops, that's not right. X over what? X over r. So we can think about that ratio as -3/4. Now notice I slid the negative up with the 3, not with the 4. Because remember, r is standing for radius, and you're not going to have a negative radius value if we're talking about a circle. The radius will always be positive for a circle. So I'm just going to leave that r as the positive number, and x can be negative. But that should make perfect sense to you because we're in the second quadrant. The x number should be negative. If we looked at a point, it'd be negative, comma, positive in that second quadrant, okay? So we want to find sine theta. And so yesterday we would have said sine is y over r. Looks like I need the y value. So let's go back to that formula that we know. We can call r 4. And x is -3, so squared plus y squared. Clean that up a bit. 4 equals the square root of 9 plus y squared. I'm going to square both sides. It gives me 16 equals 9 plus y squared. Subtract the 9 over 7 equals y squared. So when you square root both sides, you're going to get plus or minus square root of 7. Okay, but don't forget, over here, we said that sine theta was supposed to be positive, right? So make sure you use the positive value, y equals square root of 7. So then sine theta is going to be the square root of 7 over our r value, which was 4. Tangent theta, we know tangent theta is y over x. So that's going to be square root of 7 over our x value was -3. So negative square root of 7. Number 8, find sine theta and cosine theta given that tangent theta is 4/3 and theta is in quadrant 3. So make sure you pay attention to this information right here. That's going to be important because that's going to tell us the values. Sine theta is negative and cosine theta is negative, because that's what x and y are in quadrant 3, okay? So if we continue this problem like we've been doing, we know tangent theta is y over x. So again, it's not really proper to say y is 4 and x is 3, but we're gonna kind of act that way. Really, it's probably better just think about the ratio. 4/3 is the ratio of two sides of that triangle. So the numbers could actually be 8 and 6, or 16 and 12, all right? Just as long as it reduces down to 4/3. But we see that, and we can see that sine theta would equal y over r, and cosine theta would equal x over r. So it looks like we need that r value. So let's do kind of the same thing that we've been doing, use that formula. So I'm feeling like we're treating x like it's 3 squared plus 4 squared. That's square root of 9 plus 16, or the square root of 25. So we can see that r equals 5. All right, r equals 5. That's the radius of that circle that we were talking about yesterday. So then if we look and we say, okay, y is 4 and r is 5, x is 3 and r is 5, and we circle those, we will be wrong. Why is that wrong? You're on the right track, but we don't have to do that because that's when it's like a x squared equals something, and we take the square root of both sides. It's going to be plus or minus. That's kind of what she was saying, but r will never be negative because r is a radius of a circle. Okay. You have to go back to the fact that we are in the third quadrant. When we are in the third quadrant, we know that x is negative and y is negative. And so if you know that x is negative in the third quadrant, then this x coordinate, this x number is like a -3. And same way with this y number. Since this y number is negative in the third quadrant, it's going to be a -4, all right? We get -4/5 and -3/5. You have to pay attention to the quadrant because you're going to have to know if it's positive or negative. A lot of the problems that we deal with this semester are going to do that. You're going to find the number, and you're going to have to tell me if it's positive or negative.